Hey, welcome back. Alright, so here we have question 52. Like the rest of them, it's from that original group that I gave you in your Apollo book. So let's get right to it. It says, if A and B are prime numbers, which of the following cannot be the sum of A and B? So here you have your choices. One of these is not the sum of A and B. Now, cannot I put in italics. In the book, it's actually in bold. And the SHSAT is a sort of test where if a word's crucial, they'll always put it in italics or in bold letters, or they'll underline it for you, alright? So you have to pay very close attention. These things really determine everything. Alright, so let's begin. Prime numbers. So basically look at these. These are sums. It even says it here. Those are sums. Which means two smaller numbers than these, when added together, equal these. So let's think of small sums, let's think of small primes, at least prime numbers that are smaller than these. So 2, 3, 5, 7, 11, 13, 17, 19, let's see, where else can we go? And 23. Let's stop there because we're getting really close to these, aren't we? Alright, so let's see if we add any of these together, will they equal these? If they do, they're fine. But if one doesn't, then that's the one we want, and that's the answer, alright? That's what cannot means, alright? So again, if A and B are prime numbers, all these are prime numbers. And why do we pick these prime numbers, not other ones? Well, because these here are sums, and obviously they have to, if they're sums, that means some number plus another number has to equal them, which means that those two numbers that are being added up can be bigger than the sum. That doesn't make sense, right? So these are the ones we picked because these are all the prime numbers that are smaller than these that are here. So let's see, can 13 be gotten by adding any of these up together? Well, yeah, let's take a look. 11 and 2 give us 13, doesn't it? So that one's not it, because we're looking for one that cannot be. Alright? How about 16? 13 and 3. See? 13 and 3. So that's not a candidate either. How about 18? Can we get 18 by adding any of these numbers up? Yeah. 13. Look. 13 and 5. 13 and 5 give us 18. So 18 is not one of them either, because they're looking for the one that cannot be a sum of these. So whichever ones can be a sum, like these have been so far, we have to disqualify them. So let's go 25. We can. 23 plus 2, which leaves us just with 27. How do we know? Well, let's try getting there. Nothing will give us that. Look at all these numbers and try adding them up any way you want. They'll never give you 27. So 27 is our answer. This video is nice and short, except let me take a minute to tell you something. Let's take a look and let me think. I guess the important part about this video is really focusing on the word cannot. Some books tell you to cross out the word cannot, and then look at all the answers, and look at the one that stands out to you. So all of these have something in common, and what they have in common is that when all these numbers are added up together, well, when two of these numbers, and there's many numbers in this pile, when two of these numbers are added up together, they'll always give you some of these. And this is like the odd one out. But really, I like to focus on the word cannot, because really they do you the favor and they focus it for you by underlining it or making it bold or italicized. So here again it says if A and B, both of them are, if A and B are prime numbers, which of the following cannot be the sum of A and B? And since we know sums are large numbers made up of smaller numbers, well, we thought of all the smaller numbers than the numbers here. And since the biggest number was 27, we stopped at 23, because after 23 comes 24, that's not prime, then comes 25, that's not prime, 26, that's not prime, and obviously can't be 27 itself, right? So we made a whole list. And then what we did was get one number and some other number, any two we want, and we try to figure out if, when added together, they can equal those, and they did. The only one that we couldn't get was 27. That made 27 our answer, alright? So that's this one here. Until next time.